Bismillahirrahmanirrahim. Hello everyone. Our today's topic is nutritional importance of carbohydrates, BMI, BMR, glycemic index, and malnutrition. As we go along, we'll discuss each of these topics one by one. Our today's learning objective are BMI, body mass index, BMR, basal metabolic rate, glycemic index, glycemic load, dietary carbohydrates, and malnutrition. These are the topics that we will be discussing in the next few minutes. So let's start with body mass index that we have already done a little bit in the last lecture. BMI, that is body mass index, is person's weight in kilograms divided by the square of height in meters. It's a ratio between height and the weight of a person, and that tells the state of health about the person. So BMI is weight in kilograms and divided by meter in a square, height in meter is square. And this can be actually done separately, but just by simple weighing machine and scaleometer. But there is a specific instrument which is used for this purpose is a stadiometer. A stadiometer is the one which has the weighing machine as well as the measurement of the height. So a stadiometer is used to measure BMI. So whatever the result that we get, then that tells us about the health state of our body. A high BMI can indicate high body fat. Obviously, it becomes more and more fatty. So BMI provides a measure of relative weight adjusted for height. So this allows comparison both within and between the population, that what kind of people are there. So whatever result that we get from the BMI, it tells us about the health state of the individual. For example, if we get the BMI value from 18.5 to 24.9, that is the indication of a healthy person. But if we get the values from below 18.5, then it means the person is lean. Is not healthy, is a lean. Then if we get the value from 25 to 29.9, then it indicates the overweight. And if we get 30 or equal to 30 or more, then it indicates that the individual is obese. And obviously, if it's more than 40, then it indicates the extremely obese person. So healthy BMI is considered, as I pointed out, 18.5 to 25. BMI 26 to 30 is considered overweight. BMI 30 plus is considered obese. BMI is less than 18 is considered underweight. All of these considerations apply to adult BMI measurements. Benefits of healthy BMI. What is the advantage of that one? Yeah. Benefits of healthy BMI are, number one, lower risk of developing type 2 diabetes, increased joint longevity, decreased risk of cardiovascular disease, including heart attack and stroke, and decreased risk of developing cancer. BMI greater than 30 can cause or be a contributing factor to type 2 diabetes, hypertension, stroke, and heart attack. The risk of developing these conditions is lower when a healthy BMI is maintained, that is between 18.5 to 25. So how one can maintain the healthy BMI? Depends on the healthy food choices. Limit carbohydrates intake to 118 grams a day for women and 240 grams a day for men. Increase the intake of vegetables. Limit simple carbohydrate intake. Increase whole grain intake. Decrease consumption of white foods, processed sugar, white bread, white rice, and so on. That is, those are the ones which contribute towards more and more after digestion towards the blood glucose level. Nutritional facts. Nutrition facts for all food purchased at a grocery store can be found on the packaging containing the food. This tells us that whatever we are buying, what are the actual contents of these nutrients in that particular package that we are buying. The carbohydrates and fats, especially saturated fat, are the most important things to look for. Low carbohydrate foods with a small amount of fat are the best. Cooking also affects the quality of the food. When making meals at home, focus on vegetables being the largest part of the meal, followed by lean protein and then a complex carbohydrate. Why complex carbohydrate? Because the complex carbohydrate takes time for digestion and it releases the glucose slowly and gradually. When preparing vegetables, try to use calorie-free spray butter or season them with spices instead of using regular butter. Meat portion should be about the size of a deck of card or 3 to 4 ounces. In order to become a healthy person, keep the BMI within the healthy range, then you have to require to increase the physical activity as well. Increasing physical activity burns more calories and assists in weight loss. That is, increasing physical activity, it burns more calories because it has to utilize the carbohydrate and other nutrients for the production of calories which are required during the exercise. Calories and assist in weight loss. 30 minutes of moderate physical activity, 3 to 4 times a week is recommended for healthy lifestyle. Moderate exercise includes walking at a fast pace, a slow jogging, riding a bicycle, fast enough to break a sweat, and so on. Maintaining a healthy BMI. Once a healthy BMI is reached, it has to be maintained in order to continue the health benefits associated with it. Maintain a healthy diet and continue to exercise regularly. Don't let all your hard work go. Keep it up. Coming to basal metabolic rate, BMR, basic metabolic rate. What do we mean by basic metabolic rate? BMR is the measurement of the minimum calorie requirement our body needs to stay alive in a resting state. That is, it is the amount of calories our body needs if we are to stay in bed all the day. That is, we are not doing anything, we are just lying down, then whatever the minimum amount of calories required is known as the basic metabolic rate, basic or BMR. The question is, how many calories are required to maintain a BMR? About 70% of our calorie intake is responsible for just supplying our BMR. If we don't do anything, just we keep on Just lying down, still our body is working. Heartbeat is going on. The blood is flowing. And the other things, we are breathing as well. So all these physical processes, physiological processes require certain amount of energy. So the energy required during a minimum, a complete at rest is BMR, and about 70% of our calorie intake is responsible for just to support our BMR. It means if we don't do anything, still it doesn't mean that we don't have to take food for the production of energy, but we have to have the, the food of the calories equivalent to 70% to keep our body maintained and keep on going at a slowest rate, that is at a resting state. So we need calories too. Why we need calories at rest? We need calories to pump our heart, to breathe, control our body temperature, and number of many other things. A person on the average requires 2,500 kilocalories per day. However, it depends on person's physical activity. If the person is doing more physical activity, it may require more calories. If it is not, then it may require less or even normal amount of calories. Coming to respiratory quotient. What does that mean? Respiratory quotient is defined as the ratio of volume of carbon dioxide produced to oxygen consumed. That is, the amount of oxygen consumed during the oxidation of macromolecules and versus the carbon dioxide produced. We have three main macromolecules: carbohydrates, proteins, and fats. These are the ones which produce energy. And these are the ones, these are normally oxidized. So carbohydrates, when we oxidize carbohydrates, then the amount of carbon dioxide produced and the amount of oxygen consumed is same. So 50-50. So it means amount of oxygen divided by amount of carbon dioxide produced, then gives you the respiratory quotient that comes out to be 1. So when we oxidize proteins, then the amount of oxygen consumption is less as compared to the amount of carbon dioxide produced. So the amount of carbon dioxide, oxygen divided by the amount of carbon dioxide produced will give you the respiratory quotient of protein that comes out to be 0.8. And similarly, when we oxidize fat, then the more amount of carbon dioxide is produced as compared to the oxygen consumption, and the RQ, that is the respiratory quotient, comes out to be 0.7. So the respiratory quotient varies for mixed diet, because mixed diet means the diet having carbohydrate, protein, and fat. So therefore, the mixed diet, depending upon the content of any of these three food materials, then the respiratory quotient comes out to be somewhere from 0.7 to 1, often around 0.8 to 0.85. Recommended dietary allowance. A healthy person, how much different nutrients, macro as well as the micronutrients one needs. This table tells you the average amount of these nutrients. Carbohydrate 400 gram, fat 70 gram, protein 56, essential fatty acids 4 gram. Remember, the essential fatty acids are those which cannot be synthesized in our body, but we must take them in the food from outside. Then, as far as the vitamins are concerned, vitamin A, we need 600 microgram, vitamin D, 5 microgram, because needed for the development of bones. Vitamin E, we need 10 milligram, K, 70 microgram, folic acid, which is also one of the B complex, 200 microgram, calcium, 800 milligram, because this is essential for the development of bone and teeth. And phosphorus also take part in the development of bone and teeth, and we need 800 milligram per day, and iron 10 milligram. Now, nutrition, as far as the nutritional importance of carbohydrates. Importance of carbohydrate. Why do we take carbohydrate? What is the importance of that one? The first importance of carbohydrate is that providing energy for regulation of blood glucose. Providing energy and regulation of blood glucose. When we burn carbohydrate, that is digest carbohydrate, it provides energy. And from the carbohydrate, when it is digested or the macro starch or glycogen, then it is converted into glucose and it increases the blood glucose level. So the carbohydrates are the one that they providing energy as well as they regulate the blood glucose level. Second important function of carbohydrates is energy storage. The carbohydrates that we take in the diet are used to provide energy for various functions of the body, and the excess are stored in the form of glycogen for later use. Because whatever carbohydrate that we take, it is not necessary that all of them will be metabolized. It will metabolize according to requirement of the body, and if there is an excess, then that has to be stored in the form of glycogen, so that whenever we need glucose or energy later on, then it has to be there for later use. The third function of carbohydrates are building macromolecules. Carbohydrate itself is a macromolecule, but besides this, we have other macromolecules as well. For example, protein, lipids, and nucleic acids. So, maintain function is to provide energy. Building macromolecule, the main function is to provide energy. Obvious one. Some glucose is converted to ribose and deoxyribose for other molecules such as RNA, DNA, and ATP. So the sugar, the carbohydrate that we take, it may be converted to some other type of sugars, ribose and deoxyribose, which are the part of the nucleic acid, RNA and DNA, and as well as ATP, which is the currency of the cell. It is utilized to make NADP. NADP is a coenzyme, nicotinamide adenine dinucleotide phosphate, which is important for protection of oxidative stress and used in many biochemical reactions. If all the energy of glycogen storing capacity and building needs of the body are met, excess glucose can be used to make fat. Obviously, if we take much more and more carbohydrate in the form of or the stored glycogen, then if there is an excess, then it has to be used for the synthesis of fat. So nutritional importance, as I pointed out, dietary carbohydrates are the chief source of energy, as we have discussed. They contribute about 60 to 70% of total caloric requirement of the body. And from the nutritional point of view, carbohydrates are divided or grouped into two categories. One is the available carbohydrates, and the other one is the unavailable carbohydrates. What do we mean by this? Available carbohydrates are the ones that utilized by the body, that can be utilized by the body. For example, starch, glycogen, sucrose, lactose, glucose, fructose, and so on. The unavailable carbohydrates are those which are not digested by the body. For example, cellulose, hemicellulose, pectin, gums, and so on. But they are necessary for the intestinal movement. Functions of carbohydrate, as we have discussed earlier, I'm just repeating. Major source of energy. Carbohydrates are the principal source of energy, supplying about 60 to 70% of the caloric requirement of the body. And there's another function of carbohydrate is protein sparing action. Protein sparing action means that if we have, in order to provide energy, we can metabolize carbohydrate, proteins, and lipids. But if we also burn out proteins, metabolize proteins, but because the proteins are essential for the development of the growth of the tissues, and if we keep on using that one, so one we cannot be used proteins for the tissue development. So therefore, the carbohydrates are the ones which provide more energy, whatever is required for the protein biosynthesis, and this is known as the protein sparing action of carbohydrate. That is, it gives more energy for the normal functioning, which must have been provided by the proteins. So carbohydrates come to the rescue and spare the proteins from being misused for caloric purposes, because the main function of proteins is to develop the tissues. Absolute requirement by brain. Remember that our brain keeps on working all the time, and our brain requires 120 grams of glucose per day. It's a huge amount. 120 grams of glucose is required by our brain daily. The brain and other parts of central nervous system are dependent on glucose for energy. Then the second function is required for the oxidation of fat. Carbohydrates, when metabolized, then they take part and they help in the oxidation of fat. How they do it? Carbohydrates are converted into after metabolism, converted into acetyl coenzyme A is formed in fatty acid oxidation. Acetyl-CoA combines with oxaloacetate. They later is predominantly derived from carbohydrates. See, the carbohydrates, when metabolized, then keeps on degrading and synthesize different type of acid, oxaloacetate, which is one of the components synthesized through the oxidation or the metabolism of carbohydrates. Acetyl coenzyme A is the one which is also formed from the metabolism of fat, metabolism of carbohydrates, metabolism, and so on. Fats burn in a fuel of carbohydrates. That is, when we need energy, carbohydrates, once is synthesized in acetyl coenzyme A, and then it uses the oxidation of fats and burn the fat. What do we mean by burning of fat? The fat, which is composed of triacyl glycerol combined with the 3 fatty acids. So during this process, during the digestion process, the fatty acids are released, and then those fatty acids are oxidized through the beta oxidation, and we get acetyl coenzyme A, and that is used for the different metabolic processes. Excess utilization of fats coupled with deficiency of carbohydrate leads to ketosis. Because if there is less carbohydrate, and in order to maintain or compensate the energy from the oxidation or metabolism of fats, then the metabolism of fat, when through the beta oxidation, we get the formation of acetyl coenzyme A, and excess acetyl coenzyme A, then it leads to the synthesis of ketone bodies, and it is known as, in increase in the blood, known as ketosis. We also need to use carbohydrates for energy supply for the muscles, because muscles keep on working all the time, and then the muscle glycogen, which is a storage form of glycogen in the muscles, is broken down to lactic acid through the process of glycolysis and to provide energy for muscle contraction. Another function of carbohydrates is synthesis of pentoses. Pentoses, remember, are very important sugars. They are constituents of several compounds in the body, for example, ribose for RNA and deoxyribose for DNA. And at the same time, they are also components of the coenzymes like NAD, nicotinamide adenine dinucleotide, and FAD, flavin adenine dinucleotide. These pentoses are produced in the carbohydrate metabolism through exose monophosphate shunt or exose monophosphate shunt. Synthesis of non-essential amino acids. Remember that the essential amino acids are those that cannot be synthesized by our body. They must be supplied or taken through the diet. But the non-essential amino acids are the ones that can be synthesized in our body. And how they are synthesized. So carbohydrates, after digestion, then form the acetyl coenzyme A, and then from there it can be either go to the synthesis of amino acid or goes to the synthesis of fat. So the carbohydrates can be used for the synthesis of non-essential amino acids required by the body. The intermediates of carbohydrate metabolism, mainly the keto acids. That is, for example, pyruvic acid. Because when we oxidize glucose through glycolytic pathway, the last step is the formation of pyruvic acid. And that pyruvic acid can either, under anaerobic condition, convert it to lactic acid, or under oxidative, in the presence of oxygen, then it can be converted into acetyl coenzyme A, may go into TCA cycle, or it may go for the synthesis of fat. So pyruvic acid serve as a precursor for the synthesis of non-essential amino acids, as well as for the synthesis of fat. Excess consumption of carbohydrates leads to the formation of fat. How? As I just pointed out, that the pyruvate which is formed is after oxidative oxidation, it is converted into acetyl coenzyme A. That can either be goes to TCA cycle for further oxidation to carbon dioxide and water, or acetyl coenzyme A can be used for the synthesis of fat. Sources of carbohydrate. Carbohydrates are abundant in several naturally occurring foods. For example, table sugar, then 99% carbohydrate, cereals, 60 to 80%, pulses, 50 to 60%, roots and tubers, 20 to 40%, and bread, 50 to 60% carbohydrates. Requirement of carbohydrates. In a well-balanced diet, at least 40% of the caloric need of the body is met from carbohydrate. Coming to glycemic index. Glycemic index is the one that is controlling our body's blood sugar, controlling our blood sugar through glycemic index. What do we mean by glycemic index? What is glycemic index? A scale that ranks carbohydrates by how much they raise blood glucose levels compared to a reference food. That is, there's a one standard food material that is considered as a reference, and whatever the amount of glucose that reference produced, in comparison to that one, how much amount of glucose is produced by the diet or the food, that the material that we are taking, and that is known as the glycemic index. Coming to glycemic load, the glycemic load of a food is a number that estimates how much the food will raise a person's blood glucose level after eating it. So glycemic index means whatever food that we take, then that it is the one that tells us that how much the food will raise our blood glucose level after we take that particular food. So glycemic load takes the amount of carbohydrates in grams in a single serving into account. That is, if we take certain diet, single serving, and after digestion, that how much amount of glucose is produced. So glycemic load can be calculated by glycemic index multiplied by carbohydrate in grams divided by 100. Glycemic index explains how carbohydrates may affect blood glucose level, whereas glycemic load takes into consideration every component of the food as a whole. Now, remember, glycemic index is the one that explains how much carbohydrate may affect blood glucose level, only and only carbohydrate. Whatever carbohydrate affects the level of glucose, that is glycemic index. But glycemic load means that the takes into consideration every component of the food as a whole. That is, it's not only carbohydrate, but whatever the other food like protein, fat, and so on are the ones that produce certain amount of glucose along with the carbohydrate. So when all these three contribute, then it is known as glycemic load, and if only carbohydrate, then it is known as glycemic index. Glycemic index versus load. The glycemic index ranks food from 1 to 100 based on how quickly they are digested and get into bloodstream. The higher the food ranked, the quicker it raises the blood glucose level. For example, if we take simple glucose, it quickly raises the blood glucose. If we take starch, it will take some time because it has to be digested into glucose. The glycemic load, on the other hand, takes the amount of carbohydrate in grams in a single serving into account. Glycemic index, how one can determine. For example, if you want to determine the glycemic index, then you have to take 25 to 50 grams of carbohydrate test food. Take blood samples in the first hour every 15 minutes, the second hour every 30 minutes, and the third hour after 1 hour, and then plot the value, test food response compared to reference food response. Average glycemic index of 8 to 10 volunteers, when it was taken, the glycemic index of the test food tells you about this curve. These curves will come later on as well. So glycemic index ranking, 0 to 55, low, moderate 56 to 69, and high 70 or more, means that the carbohydrate which is digested and if raises the blood glucose level as compared to the reference food about up to 55, then it is low. If it raises slightly more, 56 to 69, it is moderate, and high 70 or more. Look at these the glycemic index of the graphs that we have discussed in a moment, like this one. You see, this is glucose, which is taken as a reference, 100% level of the blood glucose. Then, in comparison of this one, if we take the same amount of spaghetti, then it increases the blood glucose level, not 100%, but to a lesser extent. The same is right here for the second 100% glucose. And if we take the white bread, then after digestion, it raises the blood glucose level more as compared to the spaghetti. So the glycemic index, it gives out about 70%, and the spaghetti gives about 41%. Meaning that how much glucose it raises the glucose after digestion. Factors influencing glycemic index ranking. Physical entrapment. Brands act as a physical barrier that slow down enzymatic activity on the internal starch. So consider this one. This seed has the outer layer bran, endoplasm, and the germ. Bran, as I pointed out, acts as a physical barrier that slows down enzymatic activity on the internal starch because enzyme has to enter to digest the internal starch. So it gives you lower GI or lower glycemic index. All brands about 38%. Then another kind of food that the pumpernickel bread gives you 50%. Higher GI gives you a bagel is a kind of food, and cornflakes about 92%. Factor influence GI ranking. Fiber. Soluble fibers transform intestinal contents into gel-like matter that slows down enzymatic activity on starch. Fiber is very, very important because if we don't take fiber in the diet, then it leads to the constipation. So, different type of foods gives us different glycemic index. For example, lower glycemic index one can get from apple and rolled oats, and higher glycemic index whole wheat bread or Cheerios, 74%. Factors influencing glycemic index ranking: fats and proteins, content of the food. Fat and proteins slow down gastric emptying and thus slow down digestion of starch. So, for example, peanut, potato chips, and special food gives you lower glycemic index. Higher jelly beans, baked potatoes, cornflakes, and so on gives you the higher glycemic index. How the processing of food processing then influence the glycemic index. Highly processed foods require less digestive processing because the contents are denatured and that can easily be digested by the enzymes. Lower glycemic index, for example, oat-fashioned rolled oats, and higher quick 1-minute oats that gives you more glycemic index. Cooking. How cooking affects the glycemic index ranking. Cooking swells starch molecules and softens food, which speed up the rate of digestion. It means cooking helps the digestion of food, and again, what food gives you lower glycemic index and higher. This one, the higher, and this one, the lower. And then the spaghetti boiled 10 to 15 minutes gives you glycemic index of 44%. Overcooked spaghetti boiled for 20 minutes gives you more glycemic index because it has to be cooked and it help the enzymes to digest the overcooked food. Benefits of low glycemic index diet. What are the benefits? Are there any documented benefits to lowering the GI of one's diet? Yes. The benefits of low GI diet, for example, blood glucose, it decreases the blood glucose level, decreases blood cholesterol levels, decreases weight, decrease heart disease risk, and decrease the type 2 diabetes mellitus. So it means the benefits of low glycemic index diet has several benefits. It lowers the blood glucose, lowers cholesterol, lower body weight, lower heart disease risk, and lower the risk of type 2 diabetes mellitus. This picture shows some of the foods which having a different glycemic index. High glycemic index, there's corns and banana and so on, and the other low glycemic index that gives you the oat bran and so on. Same is right here with GI meals and snacks. GI 80% when you have the easily available carbohydrates, and it's less than we don't have that one. Glycemic index of certain foods, as we have discussed earlier. So these are the ones that give you the glycemic index, that food in glucose, 100%, because it can easily, quickly increase the blood glucose level. Carrots, 90 to 95%. Honey, 80 to 90%. Although honey is more sweeter than carrots, but honey contains most of the content of fructose. And that cannot quickly increase the blood glucose level. Bread, rice, 70 to 80%. Banana and potato, 60 to 70%. Sweet potato, 50 to 60. Apples, 40 to 45. Ice cream and milk, 35 to 40. Fructose, as you see, is only 20 to 25. And soybean, 15 to 20. Now, coming to malnutrition, another important factor of the carbohydrates and the diet. What is malnutrition? Meeting the body's needs for energy and nutrients is essential for good health. That is, in other words, a balanced diet is essential for good health. A balanced diet means it contains all the essential nutrients that are required for the normal development of the body. Intake of energy and or nutrients below or in excess of needs over the time can affect health and lead to health problems. So malnutrition means is a term which covers the problems of both under and over nutrition. Under and over nutrition. Undernutrition, what happens? Undernutrition occurs when there is a deficiency of one or more nutrient. As I pointed out, in a balanced diet, all the nutrients must be in appropriate amount. But undernutrition, when there is a deficiency of one or more nutrient, it may be mild or severe, depending upon the deficiency of the amount. Mild forms of undernutrition exist due to micronutrient deficiency. What are micronutrients? Micronutrients are the vitamins and minerals. Severe undernutrition is rare in countries like UK, but can be common in some developing countries. The body may adapt to a short period of undernutrition. Some nutrients, such as fat-soluble vitamins, are stored in the body and can be used if the diet does not provide enough. Kwashiorkor is another disease of malnutrition. Kwashiorkor is caused by inadequate intake of protein in the presence of adequate intake of calories. So the diet that we are taking gives us appropriate amount of calories, but it is deficient in protein, and that leads to the disease known as Kwashiorkor. Mostly seen in children after weaning at about 1 year of age, means that when the children start taking the semi-solid food, when their diet consists predominantly of carbohydrate. Again, Kwashiorkor is the one when we take the diet giving us appropriate amount of calories, but less amount of inappropriate amount of proteins. Now, the symptoms because of Kwashiorkor is it leads to edema, skin lesion, depigmented hair, anorexia, enlargement of liver, and decreased plasma albumin. Coming to marasmus, another disease because of the malnutrition. Chronic deficiency of calories and can occur in the presence of adequate intake of protein. Remember in that one, in Kwashiorkor, we have the appropriate amount of calories and deficiency in the proteins. In this one, the deficiency in calories in the presence of adequate intake of protein. So usually occurs in children under 1 year of age. So please remember the difference between marasmus and Kwashiorkor. Symptoms of symptoms symptoms of marasmus: arrested growth, stunted growth, extreme muscle wasting, weakness, and that leads to anemia. Obesity and its associated risk factors. Remember that if the BMI is 30 or more, then the person is obese. And when it has a BMI more than 30 or more, then what are the risks associated with the obesity? Overweight and obesity are both chronic conditions that are the result of an energy imbalance over a period of time. If you take more and more food that gives you more and more energy, then obviously the excess food keeps on depositing, and the person is becoming obese. The cause of this energy imbalance can be due to combination of several different factors and varies from one person to another one. Individual behavior, environmental factors, and genetics all contribute to the complexity of obesity epidemic. Energy imbalance effects in the body. Excess energy is stored in the fat cells, which enlarge or multiply. These are the fat cells, look at right here. Enlargement of fat cells is known as hypertrophy. Enlargement of fat cells is called hypertrophy, whereas multiplication of fat cells is known as hyperplasia. Simply enlargement is known as hypertrophy, but if cells keeps on multiplying, then they keep on increasing and multiplying, and it is known as hyperplasia. With times, excessive energy storage result into obesity. Fat cell enlargement, hypertrophy. Enlarged fat cells produce clinical problems associated with obesity due to following: the weight or mass of the extra fat, the increased secretion of free fatty acids and peptides from enlarged fat cells. Finally, in conclusion, the conditions have been found to be associated with obesity. Say, for example, these diseases have been found to be associated with increased metabolic activity of cells and obesity, and these are the ones on the right side. The diseases have been found to be associated with the increased fat mass. This one, disease because of the associated with the increased metabolic activity, secretion of the cells, but this one is found associated with the increased fat mass. So the first one on the left side leads to diabetes mellitus, hypertension, gallbladder disease, liver disease, cancer, coronary artery disease, cerebrovascular disease, that is stroke, and endocrine changes. The diseases, because of the associated with the increased fat mass, psychosocial function, obstructive sleep apnea, and osteoarthritis. Thank you.